Hi everyone, welcome to my YouTube channel Zenith GATE Mechanical. So in the previous two sessions, I have discussed the question related to the engineering mechanics as well as the strength of material. So in the today's session, I will cover the questions which was asked in the GATE 2025 from the theory of machine. So the first question is from the vibration. What is the question? A block of mass 1 kg which is connected to a spring of stiffness is 10 Newton per meter is operating in a viscous medium such that the damping ratio is equal to the ratio of damped frequency to the undamped natural frequency. Okay. So what is the data given? The data is nothing but the mass is given as 1 kg. Mass is given as 1 kg. The stiffness is given as 10 Newton per meter. And it is mentioned the damping ratio, which is generally denoted with zeta, is equal to the ratio of damped frequency to the natural frequency. And you know that the damped frequency is nothing but omega n square root of 1 minus zeta square. So if you plug this omega d value here, omega n 1 minus zeta square divided by omega n. So this omega n will cancel out. So zeta is equal to 1 minus square root of zeta square. Okay. So you have to calculate in this question, what is the damping ratio? And what is the damping ratio? Damping ratio is nothing but the zeta only. So if you take the square in the left hand side and right hand side, what you will get? Zeta square is equal to 1 minus zeta square. Okay. So that means 2 zeta square is equal to 1. So zeta is equal to 1 by root 2, which is equal to 0.705. Okay. But if you see, you have to mention the answer till two decimal places. Okay, so you have to round off to two decimal places. That means the correct answer for this question is zeta is equal to 0.71. This is the final answer. Okay, now move to the next question. Again, the second question also from the vibration only. What is the question? A system as shown in the figure below consisting of cantilever beam. This is the cantilever beam whose flexural rigidity is given as EI and the negligible mass. Okay, so the mass of beam, no need to consider. A spring with spring constant K and the negligible mass. And the block of mass is M. That means the mass of spring and the mass of beam is not given. Only the block mass is given, which is nothing but M. Assuming lump parameter model for the system, the fundamental frequency, that means you have to calculate the natural frequency in this particular case. Okay, so how you will solve this problem? So the natural frequency, you know that it is nothing but it is the square root of equivalent stiffness divided by the mass. So here, if you see, this is the spring having spring constant K, and this is the mass, and this is nothing but the cantilever beam. So you can calculate the stiffness of beam by using the static deflection relation. You know that whenever there is a cantilever beam, if the load is acting, the deflection is nothing but WL cube by 3EI, if the W load is acting. Okay. Now W by delta is nothing but the stiffness. So K is equal to 3EI divided by L cube. Okay, so this is the stiffness of beam. Stiffness of beam. Now, this block of mass, you can assume it is connected with the stiffness of beam and the spring stiffness, because the block mass M is connected with these two in the parallel. Okay, so if I will draw, the diagram. So this is basically the stiffness of beam, and this is nothing but the stiffness of spring. And both are connected to a mass, which is nothing but, okay. So this is a parallel combination, and you know that how you will calculate the equivalent stiffness? Very simple. The equivalent stiffness is nothing but stiffness of beam plus stiffness of spring. Stiffness of spring. So stiffness of beam is given as 3EI divided by L cube, and this is plus K. So if you put in the first equation, which is the natural frequency formula, so omega n can be calculated as 3EI divided by L cube, three EI divided by L cube plus K and divided by mass. Now you can check which option will be the correct for this question. Okay, so 3EI by L cube, but here is the 2m. Now you can see here the option D is the correct answer. For this question, the choice D is the correct answer. Okay. Now the next question from the theory of machine, that is from the gear chapter. A pair of spur gear is required to maintain a velocity ratio of 1:2. The module of gear is 10 mm. Addendum is given as 10 mm. If the operating pressure angle is also given, that is 15 degree, the minimum number of teeth you have to calculate on the pinion so that there will be no interference. There will be no interference, and you have to give the answer in the integer. Okay, that means you have to round off to the integer value. Okay, so let me first of all write the given data. The velocity ratio, if you see, what is the velocity ratio? 1/2. That means, can I write the gear ratio is nothing but 2, because the gear ratio is the reciprocal of velocity ratio. And the module is given as 10 mm. And addendum is given as 10 mm. Addendum is given as 10 mm. And the pressure angle is given as, which is denoted with phi, is nothing but 15 degree. Okay, so what you have to calculate? You have to calculate how many number of teeth on the pinion so that there will be no interference. Okay, so TP value you have to calculate. Okay, so you already know to avoid the interference, to avoid the interference, the minimum number of teeth on gear is nothing but 2 times of fractional addendum of gear divided by square root of 1 plus 1 by g, 1 by g plus 2 sine square phi minus 1. Okay, so from here you will get the number of teeth on the gear. For calculating the number of teeth on pinion, you know already the gear ratio. Okay, so the fractional addendum of gear and the fractional addendum of pinion will be equal to 1 only, because the total addendum is nothing but, it is given as 10. So the fractional addendum is nothing but 1 only, because the addendum is given as a 10 m. Okay, so 2 into 2 into this value will be 1. So 1 plus g, gear ratio is 2. So 1 by 2 plus 2 sine square 15 square root minus 1. Okay. Once you will solve, you will get the number of teeth on the gear will be 48.78, which is approximately 49. Okay. You know that the gear ratio is nothing but the number of teeth on the gear to the number of teeth on the pinion. Okay. So from here, you can easily calculate the number of teeth on pinion is 49 divided by 2. So 24.5. Okay. So 24.5 teeth can't be possible. That means the number of teeth on the pinion, it should be an integer. You can take the higher value, that is 25. So based on this teeth on pinion, you can again calculate the number of teeth on gear, which is nothing but 50, because the gear ratio is 2. So this is 25, this is 2. So the t value will be 50. But in this particular question, you have to you have to calculate the value of number of teeth on the pinion. So what will be the correct answer? The correct answer for this question is nothing but the teeth on pinion is 25. Teeth on pinion will be 25.